So hello everyone, and welcome to the kickoff for the 10th Ocean of Data Challenge Coastal Clarity. Before we get started, I would like to begin by acknowledging that we are currently located in Mi'kma'ki, the ancestral unceded territory of the Mi'kmaq people. This territory is covered by the Treaties of Peace and Friendship. We would like to acknowledge the Indigenous people whose traditional lands we are on today and ask that everyone take a moment to consider the territory in which they are situated as well as their own personal responsibility in the processes of reconciliation. Thank you, Sydney. Perfect. Okay, so for tonight's agenda, we're going to start by meeting the Ocean of Data team. Then we're going to move on to the challenge overview, the speaker presentations. We're going to have a panel discussion. Then I'll share some more challenge details. And finally, we'll end with a question and answer period about the challenge. Let's get started with an introduction of the Ocean of Data team. Our Ocean of Data team is a collaboration between three groups, DeepSense, COVE, and ShiftKey Labs. And my name is Brogan, and I'm the communications specialist here at DeepSense. For those of you who don't know, DeepSense is a project based out of Dalhousie University in Halifax, Nova Scotia. And while our home is at Dalhousie, we actively partner with universities and colleges across Atlantic Canada. And our focus is working with companies in the ocean sector who want to leverage data to create a smarter and more sustainable ocean economy. We connect these companies with the next generation of AI, machine learning, and data experts, aka you guys. These opportunities can take the form of master's research projects, co-ops, or internships. Past projects have covered a wide range of topics, including data analytics, collection, visualization, cleaning, processing, as well as AI and machine learning. If you're looking to expand your skills, work on real-world projects, and gain valuable industry experience, be sure to submit your information to our student pool. Now, Sydney, would you like to give an overview of COVE?
Of course, yeah. So COVE is an innovation hub and technology park that's focusing on using and making new innovative marine tech. What that actually means is that we are a support systems for other companies, organizations, or research groups that are interested in learning more about the oceans, making new products, doing research, etc. One of the ways we do that is through our workforce development program, and that's where my role comes in. I'm the training and education coordinator. So my job is to help build the workforce pipeline down the road to get people interested in working in the industry. And a part of that is working with groups like DeepSense and ShiftKey to make challenges to give students a hands-on deep dive into what it's actually like to work in the oceans industry, especially on the AI and data side, which is becoming more and more prevalent as the years go on. You can go ahead, Emily.
Great, thanks. My name is Emily Fenton. I'm the manager of ShiftKey Labs. ShiftKey is located in the Faculty of Computer Science at Dalhousie here in Halifax. We are one of the province's sandboxes. This is a provincial project that introduces and facilitates innovation and entrepreneurship among students across the province. ShiftKey is devoted to computer science and technology, and we have a new focus on skills development, so bringing technical skills to folks who are interested in it, with a special focus on making sure that they're job ready. So trying to get people into tech fields as much as possible, recognizing that it's a booming industry here in Nova Scotia. So happy to be here tonight and hearing from the experts on the panel.
Amazing. Okay, so this data challenge invites participants to explore how coastal monitoring data can be leveraged to develop innovative solutions that enhance the resilience of our coastlines. And participants will answer the ultimate question, how can we promote coastal resilience? So why are coastal areas important? Coastal areas are important for many reasons, one of which is biodiversity and ecosystem services. Coastal areas such as salt marshes and estuaries serve as important habitats for numerous species, including migratory birds, marine mammals, and fish. These ecosystems play a vital role in maintaining biodiversity and stabilizing food chains across marine and terrestrial environments. Nutrient cycling and carbon sequestration are just two of the many essential ecosystem services that coastal areas provide. Next up is the economic value. Coastal areas drive our region's economy through fishing, aquaculture, tourism, and shipping. These activities employ thousands of people and contribute significantly to the regional exports and economic growth. Coastal areas also provide us with resources ranging from seafood and minerals to renewable energy and construction materials. Another major benefit of coastal areas is the protection they provide. Coastal areas act as buffers protecting inland regions from storm surges, flooding, and erosion. Salt marshes, dunes, and other coastal features can also absorb wave energy, which reduces the impact of extreme weather events that are becoming more frequent due to climate change. Coastal areas have influenced the culture, history, way of life, and identity of Atlantic Canadians for centuries. This reflects the deep connection to the sea shared by both Indigenous and settler communities. Maritime traditions, historic landmarks, and seafaring tales celebrate this heritage and attract visitors from around the world. So, as we can see, coastal areas in Atlantic Canada serve as vital habitats for a wide array of marine life and play a central role in the region's economy, culture, and way of life. However, they are increasingly at risk from the impacts of climate change. The melting of glaciers and ice sheets, coupled with the thermal expansion of water, is leading to increased sea levels. Warmer ocean temperatures, increased moisture in the atmosphere, and changing atmospheric patterns are leading to stronger, more frequent, and more intense storms. As oceans take in extra carbon dioxide from the atmosphere, the water becomes more acidic, which can weaken the shells of marine animals and disrupt ocean ecosystems. As climate change alters water conditions such as temperature, salinity, and acidity, many coastal species lose their habitats, and this leads to a decrease in species diversity. And finally, with the rising sea levels, more intense storms, and the loss of natural barriers, coastal areas experience more powerful waves which wear away beaches and shorelines more quickly. These are just a few of the many impacts of climate change on coastal areas. The environmental and socioeconomic effects of climate change are often complicated by their interconnected nature, with various factors influencing and exacerbating one another. Coastal monitoring involves the collection, analysis, and interpretation of data related to coastal ecosystems. It is essential for understanding the health of marine ecosystems and the socioeconomic effects of climate change on coastal regions. Coastal monitoring enables early detection of environmental changes like sea level rise and pollution, which allows for timely interventions. It also supports informed decision-making for resource management and helps communities prepare for natural hazards, reducing risks to people and infrastructure. Coastal resilience refers to the ability of coastal ecosystems and communities to withstand, recover from, and adapt to environmental stressors. Building resilience in coastal areas helps protect communities, infrastructure, and jobs from natural disasters. It also supports healthy ecosystems and ensures the continued provision of vital services. Together, effective monitoring and resilience building initiatives are crucial for safeguarding coastal regions and ensuring they continue to support both marine life and the communities that depend on them. So now we're going to move on to the speaker presentations. Participants, feel free to send any questions that you may have for the speakers into the chat, and we'll get to them at the end of our panel discussion. And for the speakers who sent their slides, just let us know when you want to advance to the next slide. Tonight, we have three incredible speakers who have volunteered their time to share their experience and insights with us. We have Joy Liu, who is the Data Acquisition Coordinator at Ocean Tracking Network, Amari Camarena, who is the Coastal Science and Engineering Manager at CBCL, and Nicole Torrey, who is the Coastal Monitoring Program Coordinator at CMAR. Our first speaker tonight is going to be Joy. Joy holds a Master of Science in Statistics from Dalhousie University and works as a data acquisition coordinator at the Ocean Tracking Network. Currently, her focus is on data quality control. In addition, she participates in developing different R programming packages to support fisheries scientists in visualizing and analyzing their data. Joy is also actively engaged in research focused on fisheries stock assessment and animal movement modeling. Additionally, she serves as a faculty mentor for those interested in improving their statistics and research skills. So now, Joy, we'll let you take it away.
Oh, data challenging, it's quite familiar for me. I was like participating in those challenges for current several years, and I won several times this time. But this time I'm gonna to become a speaker to talk about what I have done in the past and what what I can give some suggestion to some folks who want to win something or want to achieve some different stuff. So as people, probably lots of students know me, I was hanging around in computer science department for several times, for a long time. But yes, I finished my master's as statistics at House University. Immediately after I graduate, I was accepted by Ocean Tracking Network as data acquisition coordinator. That started the journey, but I started my ocean journey since I was in a undergrad student. We're doing some ocean science, build up some modeling and a stock assessment model. And I'm gonna to talk about my journey and my work moving on. But first, I want to talk about what Ocean Tracking Network do. So my company is doing. So if you heard of the Ocean Tracking Network, you would probably know tracking. It's a very important word in my company. So a lot of people ask why we have to track those animals. It's a good question. So the important answers are as following. So we want to know how many fishes are in this area. So Fisheries and Oceans Canada can set up different policies for how many fish each individual can catch each year. So that's the first reason. Then the second reason is the design marine protected areas. So some species, for example, white sharks, we noticed that it's recently endangered. So we want to design some marine protected areas so we can forbid some ships in the summer season or some season when those white sharks migrated in some area. So we're gonna to protect them. Environmental condition and the prediction of future animal distributions. So this is a very interesting topic. And last hackathon, we discussed about this animal distribution. So probably people didn't know that long time ago. So the dominant species in Nova Scotia is cod. Now it's changed to lobster. So those kind of dominated animals is changing. Why is that? We want to know the reason. So this is the third reason. We want to know how can we predict future animal distribution that can be beneficial for agriculture and also fishery and stock assessment as well. The last but not the least, because we said environment change can affect animals' movement and growth. Also, animals' growth and movement can also impact our environment. So how they mutually affect each other. Lots of researchers, scientists are doing this research nowadays. So those four reasons have been done in my labs during this past 4 years. So I know that, but there's more reason. So when you're doing the research, you will say there's much more reason behind why tracking. So what I want to say is tracking is necessary and also it's important. So what are the animals we are tracking? So the high valued animals. So for example, seals, salmons, lobsters, crab, those kind of animals we're gonna to track. And depending on what kind of animals, we have different tracking methodology. So if you are interested in how we're gonna to track this animal, how we do not have a detection and how the data looks like, please come to the ocean industry crawl on November 13th, maybe. Yeah, if come to that crawl, so you're gonna to go to OTN, we will have some expert to talk to you how we're gonna to track those animals. It's super cool event, so please come. And also after that event, there's a networking event, so please come. There's an expert as well to talk to you how we're gonna to track this animal. Okay, so I know lots of people, lots of students like me from computer science or stats background don't have any knowledge about the oceans. You're lucky because I can tell you what I did in the past 3 years. So I'm going to show 2 examples what I did related to the ocean challenge. So first of all, we can do a scallop sustainability. So it doesn't have to be scallop. My research was focused on scallop because I like eating scallop. That's the main reason. And also scallops, it's very good for your health, and it comprises the 5th largest fishery industry in Canada. So it's important to know what's going on for scallop sustainability. And DFO must adjust fishing policies to maintain scallop sustainability. And if you have a little bit of biology background, you will know scallop biomass, we call the meat weight, is the most important factor to predict its population. So based on that, we can do some research about scallop sustainability. So I went to Bay of Fundy to collect some data by my own 3 years ago. And if you have to go to Bay of Fundy, that is a very beautiful place. And so if you have never been to Bay of Fundy, you will see on the right-hand side, I create a map. The pink area is in the Bay of Fundy. And in the Bay of Fundy, we have different regions of like the fishing zone, fishing areas. So in different fishing zone, we'll have different, DFO set up different fishing policies. Why? Haha, it is because we do a prediction map for the scallop biomass. You can see. So we predicted the scallop meat weight across Bay of Fundy during 2012 to 2019. So on the left-hand side is the prediction in 2012, and the right-hand side is 2019. So from 2012 to 2019, we'll do the prediction. And you can see in some areas near Nova Scotia, the scallop biomass is a little bit larger. So based on that, we give this map to DFO. They have experts to say, okay, maybe I should adjust the fishing policies in different areas. So it is useful. We can create a prediction map. Now, another example is for the blue shark tracking. So I did that this summer. So we went for tracking those blue shark near St. Mary Bay this time. And I'm not gonna to tell you how I'm gonna track the shark, but I'm gonna to tell you what we can do for tracking animals. So we can construct animal movement prediction. So if we have an animal movement data, if you find it online or somewhere else, you can do an animal prediction model. So on the left-hand side, so you will see the black dot and the red dot. The black dot is the original data, and the red dot is the model prediction, fitted model prediction. So you can see the accuracy is pretty good. So based on that, I can predict few steps further about where these sharks were gonna to move. On the right-hand side is the prediction of few steps further, what you can do. I use the state space model to do this prediction, but you guys are computer science students or other field students, use your imagination to think about what we can do here. So DFO, when DFO look at this data, they look at this prediction, they will find it very useful because they know in several days where this blue shark we're gonna to move. So they can do something, for example, ask the farmer to be careful because this shark's aggressive, maybe we've eaten lots of other animals. So just be careful about that. So those are the two examples I gave to you guys, but don't be restricted. Think about what you can do. So because of you guys are very lucky, Emily always asks me to say, can you give some tips for students for Ocean Data Challenge? Here I'm going to give a quick tips for this Ocean Data Challenge. So any challenge, will be suitable for any challenge, the tips. So for any challenge, we were going to ask what we're going to do. So thinking about one big question, what's the object? What are we going to do? So for example, scallop, I want to think about the scallop distribution. That's what I'm going to do. Okay. And moving on, think about why it is important. why it is important? Because scallops contribute the 5th largest fisheries in Canada. So it's very important for economy and also the health. So why it is important? And how are we going to do that? Then we're going to say, okay, how are we going to do that? We want to predict scallop distribution. So what kind of strategy we're going to use? So you can think about a statistical model, machine learning model, and don't complicate the question. Never complicate the question, because sometimes we just want a pattern of how scallop moving. We don't have to bother a machine learning model. We just show the visualization, the graph, done. So your how to solve the question will always link to what is important, what's going on. And in the end, give a suitable result. So in the very beginning, if we can develop an app, that's very good. But nowadays, everybody can develop an app. So it's not like we have to compete each other to say, okay, you develop an app, I have to develop an app, I have to develop a better app. It's not like that. It always depends on what you are interested in. Why is this important? And based on that, give a suitable result. I see some people, some students give a very good heat map. We haven't thinking about those heat map before. That's pretty good. He doesn't have to give us an app that's not useful. So think about your result and think about some obvious, easy, understandable result. Sometimes we find the result students give us are too complicated to interpret it. So we don't want that. So we want something it's very straightforward, useful, and unique that can say how your team works together. So that's the tips for Ocean Data Challenge. Last but not least, I want to say this challenge is also a teamwork challenge. You can work as individual, but if you choose to work team, please use everybody's strengths to form a team. And even we have 20 days, but still you have to organize like a team, how to schedule a meeting, how to contribute equally, because we want to say how people contribute equally in this team. So we would like to see everybody's strengths. So as I said, I'm an R developer. So some useful package, R package I use for previous challenge and also my thesis are following. For example, Gelato, that's for animals detection and tracking. SDMTMB, that's a package for predicting scallop sustainability, like the biomass prediction map. And also I am in developing OTN Do. This package is easy for animal tracking visualization. And state space model, it's what I used for predicting blue shark moving model. So yeah, that's all of my presentation. If you have questions, you can collect me on LinkedIn, and also please come to the industry crawl and you can visit us in person. Yeah.
Great, thank you, Joy. So our next speaker will be Amari, and Amari is a senior coastal engineer and head of the Coastal Science and Engineering Department at CBCL. He has experience in coastal and offshore projects focusing on integrated coastal zone management, climate resilience, coastal flood risk assessment, and numerical modeling of coastal processes. Amari has managed and led numerous projects related to waves, hydrodynamics, morphology, coastal flooding, extreme events, hydraulic boundary conditions, and design of coastal infrastructure and harbors. During his career, he has gained vast experience with wave climate analysis of different coastal environments and has become an expert using different numerical models to accurately reproduce nature's physical processes. Amari has experience leading stakeholder consultations, workshops, and community engagement sessions, and coordinates expert teams in master planning and multidisciplinary projects, working collaboratively with environmental, social, marine, structural, civil, and other disciplines. So, Amari, I'll let you take it away now.
Great, thanks for the introduction. Lots of big words there, so I'll try to keep it simple as we go. Just one quick question. 5 minutes, 10 minutes, what are we aiming for the talk on my end for now?
Around 5 minutes if you
Around
could.
5 minutes. Excellent. So I'll keep it short and I'll just share my screen for a second. And then if you can see the slides, just let me know. So can you see that now?
Yeah, that's perfect.
Perfect. So yeah, thanks again for the introduction. As you said, I lead the coastal team at CBCL. We're a consulting firm in Atlantic Canada. A few of you from the region are probably familiar with what we do. There's lots of engineering and science work that we do at CBCL, but mostly interested now in the coastal work, which is what we've been doing as a group for the last 20 years or so. My background, as you said, is in coastal. So I look at coastal flooding, coastal erosion, coastal processes in general. So one interesting thing about today is that you're going to see, I guess, 3 different fields of what the coastal and ocean region has, but there's many others. So there's physical, there's biological, there's environmental, but many other pieces that are interesting within the coastal and ocean field. And for my very quick 5 minutes, I'll just show you a few slides of the development of the Canadian Coastal Information System. So this is a project that we started a couple years ago, and we're in the second phase now. And I'll just run through the main key pieces of this work so that you guys see. So the main motivation is to have, I guess, the fact that Canada has vast and diverse coastlines, and they present unique challenges, especially for coastal management, but also for engineering. So if we're trying to protect the coastline and make it resilient to climate change, we need to understand how the coastline works and how it changes. There's a significant lack of consistent and reliable data, so we're trying to tackle that and bridge that gap. And importantly, and related to what was presented just before, there's a lot of small craft harbor, a lot of fishing activities in Atlantic Canada. So we are trying to support the over 1,000 small craft harbor facilities that exist across Canada in this project. So then the key objective is to develop a reliable one-stop decision support system where that coastal knowledge and then added value data sets, which is what we've been working on for the last couple of years, can be used and leveraged in the assessment of risk planning, but also design of marine and coastal infrastructure. So to give you an overview, this has been the development of the project. We have phase 1, where we did a proof of concept development, then completed phase 2, which was the functional prototype development. And we are planning to go into phase 3 in the next months, where we'll do a full operational system that will be accessible for, I guess, users like you who are going to be feeding new data, developing new data, and using the system to, I guess, in your different fields, either environmental or design or engineering or other fields, right? So that's the general idea of the work. Interesting for this specific challenge is that we used over 50 data sources. So we looked at sea level change, we looked at wind conditions in past, but also in future projected climates. We looked at extreme water levels, including tides, storm surge. We looked at wave conditions offshore and nearshore, and we developed numerical modeling tools for nearshore conditions, ice map changes, as well as bathymetry data from across Canada, LiDAR elevations for the region, and geotechnical information. So as I said, the idea is to bring everything together into one place. Then we used existing information from our team, so from CBCL and DHI, of existing numerical models that we have for hundreds of small craft harbors and regional studies that we've completed across Canada to feed into the system that in essence is 4 key items: the map viewer, the analytics dashboard, a data repository, and a toolbox. So just to give you a sense of how those are distributed within the website that we develop with all the data, this is how it looks in the landing page. So we have all of that data in a dashboard. Then there's a data repository where you can download and process data yourself, and toolboxes where you can do, I guess, different functionalities that have been developed. This is how it looks. So each of those little circles on the screen represent a small craft harbor or a coastal asset or a coastal facility like a ferry terminal or similar. And then the interesting thing is that for each of those, you'll be able to load information and data that is already summarized per site. So this, for example, bathymetry for all of Canada. And then these are nearshore wave conditions for various return periods and directions. So you'll see the distribution of the wave heights across the region. And the idea is to expand this into all of Canada. Similarly, you'll see climatology for ice conditions and how that ice changes throughout the year historically based on the environment and climate change ice charts. information related to specific locations. So in this case, we're looking, for example, at Wood Island in PEI, so just across the Northumberland Strait, where you have a one-place stop where sea level rise, tidal levels, wind speeds, wave heights, periods, and directions are all summarized in one place. And then you can zoom in, and there's various tabs at the top where you look at water levels and compare it to your asset elevation. So if you're interested in a road, or if you're interested in a specific, perhaps wharf or pier, you can compare that elevation to different scenarios for sea level rise combined with extreme conditions. And then more data, but wave conditions, extreme values for design, because that's a big component of what we do, design of marine and coastal infrastructure. Looking at things like sea level rise from different AR5 and AR6 projections associated for the different regions across the Bay of Fundy, which was being presented before, but also across Canada, and then geotechnical information. So there's really all those pieces here. And then going very quickly, but just to show you here, this is part of the repository where you can select which type of data set you're looking for by geography or by keywords. And then the system contains all of that information that is normally scattered throughout multiple websites. And some of the examples of what you can do is bathymetry interpolation, time series analysis, or wave propagation from offshore to nearshore, so that you can get an understanding of what the conditions are like at your site. So that's a very quick overview and rundown over the system that we are developing that maybe give you some ideas of what you want to do in the challenge. But just to close up and go to the next speaker, the idea of the Canadian Coastal Information System is, as I said, to visualize, download, and process data for a lot of applications ranging from environmental, social, engineering, in other fields. But also, I guess one important thing of this that we think is the first system in Canada that has those other valued data sets that can be used for design and for risk profiling for different assets. And it's very important because we have been able to standardize the data set, standardize the decision-making process so that this data can be used in different fields. So those are a few of the key things that I wanted to mention. And then just thank the rest of the team that has been working on this. So yeah, that's, I think, what I had for my 5 minutes. Probably talked for 1 or 2 extra, but that's the overall quick intro that I wanted to give you. So yeah.
Thank you so much, Amari.
Yeah.
So our last speaker for the night is Nicole. And Nicole holds a degree in environmental science and sustainability and got her start in the ocean sector after working with the Center for Marine Applied Research, or CMAR. And she got this through the COVE internship program in 2021. As the Coastal Monitoring Program Coordinator, Nicole manages the fieldwork operations for CMAR's 70 sensor stations, which collect high-resolution coastal ocean data. Her work is focused on implementing data management best practices to ensure production of high-quality data for Nova Scotia's coastal industries, researchers, decision makers, and ocean users. So I will let you go ahead, Nicole.
Perfect. Thank you for the introduction, Brogan. Yeah, just to jump right in, when thinking about how we can promote coastal resilience in the context of my job, my focus is on collecting data and providing high quality coastal data to help inform decision-making and monitor environmental changes over time. So I'm going to dive straight into our data collection process a little bit more. As we're all aware, and as the other speakers already kind of gave good background on, coastal data is so important for resilience and decision-making. So you might be surprised to know that up until a few years ago, there was limited monitoring occurring at relevant time and spatial scales needed for decision-making here in Nova Scotia. And coastal waters are really complex with relatively high spatial and temporal variability. So offshore broad-scale monitoring efforts are not always relevant to a specific coastal location. So there are 2 examples on the screen here. On the left, data from federal research vessel surveys is typically measured much further offshore, and the data is not always applicable to the coast. And then we can get coastal data from satellites, but this may be surface level information at a relatively low resolution and might only be measured once every day or every couple of days, depending on the satellite flyover patterns. And aside from these examples, there are many localized coastal, can you go back 1 slide, please? Thank you. There are many localized coastal research efforts going on, but they're often really specific to one location or maybe one time of year. So we're not getting a comprehensive view of the data and the conditions at a location around our coastlines. So overall, there was an identified need to improve coastal data availability in the province. And that's where CMAR comes in. So at CMAR, I coordinate a coastal monitoring program which aims to fill this gap and provide high-resolution coastal data throughout Nova Scotia's coastal waters. We collect data on several different coastal variables, and that includes temperature, dissolved oxygen, currents, waves, and tagged animal detections, which we actually send to the Ocean Tracking Network. And this map shows all the locations where we have collected data. So at any given time, we have a stock of roughly 250 sensors deployed throughout the water column at 70 of these locations, and they're recording data at intervals of 10 minutes to an hour. And some of these locations have been active for almost a decade now, so we're really starting to build up these longer time series of baseline data at the same locations. And as you can imagine, these stations produce a lot of data. So in total, we have over 50 million data observation points collected between these locations now. So if you could go to the next slide, please. Just to give you a snapshot of what these data sets look like. This is one example data set from a station where we've collected almost 5 years of continuous temperature data at 5 different depths. And just from looking at these plots, we can start to pull out some interesting patterns in the data. So for example, we see stratification in the summer months, we see mixing in the warmer months, and we can see rapid changes caused by major storm events, such as hurricanes in the fall. And as we build on these time series, we'll eventually be able to have a comprehensive understanding of the environmental conditions at each of these coastal locations and begin to pick out longer-term trends and changes. Next slide, please. So I could spend an hour talking about data management alone, but I just briefly wanted to mention this. It's something that is so important to this whole program, which is ensuring that all of the data that we're producing is high quality. So to do this, we've built up some data management initiatives to reduce any opportunities for human or technological error by automating and standardizing our workflows as much as possible. And as part of these initiatives, we've written 5 R packages to automate our data processing, visualization, and flag any potential outliers or issues in our metadata. And this code is all freely available on GitHub. So if any of you are interested in using our data sets for your challenge solution, you could use these R packages to help you work with that data. Just a little plug there. Next slide, please. And we really do want people to use these resulting data sets. So all the data is free, available for download in several places. We publish summary reports to the CMAR website. So these are just kind of like a high-level overview of the conditions at each location. And then if anybody's interested in digging a bit deeper into the data sets themselves, they can download them from the Nova Scotia Open Data Portal. And most of them are also on the CEUS Atlantic platform as well. Next slide, please. And yeah, that's all. I know that was a really quick, brief overview of a complex program. So please feel free to reach out to my email on the screen there, or take a look at our website and see if you have any additional questions. Thank you.
Amazing. Thank you, Nicole. So I'm now going to pass things along to Sydney, who will be facilitating the panel discussion.
Awesome. So how we're going to do this is we have 2 personalized questions per speaker, and then we kind of have just 2 general questions that we can spur conversation with at the end. So I'm just going to start by doing 1 speaker at a time. I'll start with Joy, we'll go to Anne-Marie and then Nicole, and then we'll flip back up to Joy and go over it again. Then we can go to our general questions. If that sounds good for everyone. Perfect. So Joy, my first question is for you. What are the biggest challenges in collecting, managing, and analyzing coastal data?
I think first of all, the several reasons, but I think the most important reason is expensive. So for OTN, we have those equipment, researcher can borrow them. But the thing is that we have to spend 20K for one receiver to get this data, at least 20K. And sometimes it won't last like 1 year. It's gone. It's because the battery died, or it just disappeared or flushed away. We cannot get back to the data, and we lost the receiver. So expensive. Another one is the accuracy. So for satellite data, it's easier because it's more accurate. You can get it. But for the detection data under the water, sometimes the quality wasn't good because it's not like tracking step by step. It's when the animal come near this region, we have this acoustic release with acoustic telemetry data. We catch up the ping the animal is taking is coming by, but where it exactly is staying around, we don't know. So the accuracy is another problem. The third reason is collaboration, lack of collaboration, the knowledge about what's going on. Because when we put up those receiver and we put tag into those animals, some fishermen, they just don't have any knowledge about this. So like last time, I remember my colleague was having this argument with fishermen in Newfoundland. The fisherman, what he said to my colleague is, those receivers interrupt my fishing areas. It's like a garbage. It's like a pollution. And you guys are hurting animals. You put it into tags into the animal's body. And actually he has some, I appreciate he likes those animals. But the thing is that for that conversation, I realized the lack of communication, lack of the government to teach people what's going on, that can really affect a lot of things, and it will slow down the process of data collecting. That is why OTN has some free program for local fishermen to attend, and we have a good collaboration with Mi'kmaq people. We learn indigenous culture and how to tag this animal more morally, and they also know why tagging is very important, and we share those knowledge. So based on those three reasons, I think that's the difficulty for coasting data. If we can solve any of those, will be a big improvement for data collection.
Those are some really good points, Joy, especially the one I can relate to is how expensive it can be. Anything in academia is always a lot more expensive than you realize it is. And a lot of people don't think about that. That can really limit what you can do. Perfect. So my next question is for Amory. How can coastal engineers design infrastructure that protects communities from erosion and flooding due to rising sea levels and the increased frequency and intensity of storms?
Yeah, big question. So I think what we have to do as engineers and in general when we are working in coastal areas is to understand the conditions to which the coastline is going to be exposed to. And the key pieces that are essential to understand when you're doing any type of adaptation project along the coast is the water levels, the waves, the winds, and the ice conditions. Those are kind of like the key parameters that we would look at from the water side. But then there's a lot of other components that are important for design that would include sediment characteristics or shoreline types. So if you have a rocky shoreline, you do things one way. If you have a muddy shoreline like the Bay of Fundy, you have to do other considerations. And then those are related to the sediment characteristics, but also the geotechnical capacity of the shoreline in those sections. So those are kind of like the big high-level pieces. But then directly related to climate change, what has been really important in recent, I guess, developments is to include the sea level rise projections. Because if something is not flooding now, but you know it's already close to the edge of what a coastal storm would have on elevation, you know that with sea level rise, that is very likely to flood in 30 or 40 or 50 years from now. So taking that into consideration, it's very important. Another one that is very critical, especially for sandy environments like PEI, for example, that is a big sand castle. You need to understand how the ice conditions are projected to change in the future. Because that allows you to estimate erosion rates across the island that are going to change significantly. Because what happens now in PEI, for example, is that for a lot of the winter, there is ice that is actually protecting the coastline from those winter storms that would generally, I guess, be protected by the ice. But then in the future, if the ice is reducing, that means that all of those waves that were at present blocked by the ice are actually going to make it to the coastline and going to erode the coastline at a much faster rate than it regularly occurs at present. So those are some of the key considerations. Of course, going back to what Nicole and Joy were saying, ideally we have measured data to understand water level variations, to understand storm conditions, wave conditions. And I think I saw there in the slides that there was like ADCP deployments or pressure sensors. So those would be like key instrumentation that we would use in those type of projects to then calibrate the numerical models. So if you do a model that translates the offshore conditions to the nearshore conditions, you want to be able to confirm that it's actually doing what it's supposed to be doing. And that's where all that coastal monitoring data comes to be very handy. So that's the general overview, I would say.
Perfect. Those were some really good points. Thank you. Our next question I'm throwing over to Nicole. It's how can data from coastal monitoring systems help predict or mitigate the effects of climate change on natural ecosystems in Nova Scotia?
Yeah, good question. So if we can start to build up a strong baseline of historical data in an ecosystem, we can start to track trends and observe which coastal habitats are changing due to the impacts of climate change and how they're changing. If we only have sparse data for an area, we might not really be able to identify what the ecosystem norms are and extract kind of the trends of the changes. But if we are able to observe certain impacts related to climate change, these observations could be really key to understanding how certain anthropogenic activities could be managed so that we're not adding additional stress to an already stressed ecosystem. So for an example, data from monitoring stations like the ones that CMAR have could be used to inform policy decisions which might be put in place to protect critical habitats or species which are going to be impacted by things like fisheries management or marine protected areas. And then kind of just to expand on your question a little bit, to apply it more to an industry perspective, having this coastal data can be really important for things like the aquaculture industry and predicting things like super chill events or heat stress events, which can be exacerbated by climate change. But both of these things will cause stress or even fish die-offs, and that can be really devastating to an industry. So having this baseline data to understand conditions in an area can be really key to prevent those things.
So would tracking a heat event, kind of like an El Nino, be kind of a thing that you would be tracking with that historical data?
Yep, something like that could be a signal that we could pull out. And I think having multi-year data sets in order to track those kind of larger scale cycles is really important, because if, say, you only have data for one summer in one location, you might kind of miss that peak signal. And then if you make decisions based off of that data, they could be a little bit misleading.
Perfect. Awesome. Thank you so much, Nicole. So we're going to go right back up to Joy. So this question is, what role does long-term data collection play in improving the accuracy of predictions about fish stock responses to climate impacts?
That's a very big question, actually. So more data, kind of more accurate. That's what we all know. It's for OTM, we have a database for those data. We want to connect those data. We want to compare to those data. Sometimes we cannot say the data is at 100% accuracy, because we have a lot of long-term data. So we can analyze those data, time series analyze. Sometimes we can find, okay, why this is a peak here? Why this time of the year, scallops biomass, it's way larger than that year. We wanted to ask those questions back to the researcher and the biologist. Sometimes they can give us the answer. It's like, okay, the data might not be accurate, so there's approximate here. So we have a confidence interval to say how to analyze the data. Now, another time we're gonna to say, okay, because of the climate change, that things happen. So we have those kind of interesting pattern. So after we look at those data, we link back to what's going on, what's going on behind this curtain. It is either because the data problem or it's because something really happened. So that can give scientists more thinking about what's going on. And that's a very benefit for data connection and data analysis. And also for data prediction. So if you connect the data for several years, it's easier or more accurate for you to predict the data sometimes, but not 100%, because in 2020 to 2022 is because of COVID time. So at that time we have a very wacky data. So it's hard to predict because we have data sparsity. We don't have a lot of data because a lot of things are forbidden. So at that time we will have a very low data quality. So low data quality can affect your data prediction and also your research and lots of other things. So what I'm saying is it's always interesting and to collect those data and to analyze depends on what you are interested in. So sometimes we want to analyze a long-term period data. Sometimes we just want to analyze the short-term period data to say the seasonal effect or the spatial patterns during this year. So it really depends on your research question. So my job is to make sure the data quality it's good. So we develop some modeling for data quality control process. So if you are interested in, you should definitely come to OTN to say hello to us. We're gonna to have a tutor to teach you introduction for you to guide you to through, okay, what's going on for our data center. A lot of people think we are doing something necessary, but we are not. We are open in Dalhousie University. Every student can visit us. Yeah, so I think this is a very good chance for you guys to come to visit us. And especially if you are interested in animals tagging, there's lots of fishers there gonna to show you how to do that in the networking event. So please come.
I love the advertisement for OTN. So the next question we're going back to Emery for. How can data from coastal monitoring systems be integrated into the planning and construction of resilient structures?
Yeah, good question. So I think it goes back partially to what I was saying before, that in order for us to validate and calibrate the numerical models that we develop for the design of coastal infrastructure, we need data. So having that data in a repository and having all of those quality control steps completed on that measured data, it's very important to actually estimate nearshore conditions. And then going back to what Nicole was saying, there's also things like the duration of the data or the various cycles. So we know that wave conditions are generally higher in winter than they are in summer. And that's a trend that we can pretty clearly see. But there is also multi-year cycles that would change the conditions. And then when we are looking into designing coastal infrastructure, there's generally like the so-called 100-year wave or 200-year wave or storm that is associated to the design of specific infrastructure. The higher the risk, or I guess the higher the value of the infrastructure, you would tend to use a higher return period storm to design it. So when we look at that, the more data that we have, the more reliably that we can actually simulate those storms. So if we have a few months during the summer, that's probably not enough data to then go and design a structure that is supposed to be there for the next 75 years. So ideally, we would like to have data like the data that is available at BIO, that is more than 50 years of water level data that we can actually use to estimate extreme values of storms. So yeah, different cycles and different, I guess, timelines for the data, but that's how we would integrate it into the calibration validation and then for the extreme value analysis to design storms.
Awesome. One thing I'm really picking up is two important things for data is having data from a lot of different spaces and having it open accessible, and then having a lot of historical data to help make sure everything you're looking at is correct.
Exactly.
Awesome. So our last pre-arranged question is for Nicole, and then after I'm going to throw out a few questions that some of our students or participants have put in the chat, and then anyone in the panel can feel free to answer those whenever. So Nicole, your last question. How do you ensure data quality and consistency across CMAR's 70 sensor stations, especially given the challenges of fieldwork and diverse coastal conditions?
Yeah, good question. I think data quality is something that I could spend hours talking about. It's a really big focus of ours at CMAR, and it kind of takes up most of my time, to be honest, at work. It's just like working with these big data sets. But we do quite a few things to try and standardize our workflows and improve the data quality. And I'll just give a couple of examples here. So first, we have over 40 standard operating procedures, which detail everything from how to decide where to put monitoring equipment to what are the steps to turning these specific sensors on and working with them. How do you attach the gear to a line to deploy them out in the water? So we have really strict procedures to follow so that we can ensure that everything is consistent, so that we're collecting data consistently and we trust our deployment methods, our data processing methods, things like that. In addition to the standard operating procedures, we also do things like in-house calibration validations on each sensor before we deploy them. And these are tests that we've developed on our own just to make sure that each sensor is recording within an acceptable range, so that we can trust that data that's coming off of them during deployment. And then the last example, which I think is maybe the biggest example, is the automation of quality control tests on the data sets that are coming out from these sensors. So we, like I said, we do a lot of our coding in R, and we've automated the data processing pipeline and developed a couple of different R packages to kind of wrap up all of these different automated tests that we can apply to the data. So we have different algorithms flagging for outliers. We have gross range tests to flag for observations that are outside of the acceptable range for each sensor. We have a rolling standard deviation test to flag for rapid changes that might not be consistent with environmental norms. So having these built-in algorithms to flag the data for us really helps with consistency, so that it's not just an individual employee kind of looking at the different data sets and trying to eyeball it and make decisions about what might be good or bad data. We really try to ensure that we're reducing human error and just automating these things as much as possible.
Awesome. Thank you so much, Nicole. So the next few questions are going to be just kind of a more open roundtable discussion. So if you feel like you want to chime in, just unmute yourself and chime in. So this question is from Omar. What are your predictions regarding the opening of the Northwestern Passage shipping routes as the ice continues to melt in the north? And what geopolitical significance could this give to Canada?
No volunteers. I can try to answer that one. I don't have the perfect answer. I think it's something that people are for sure monitoring because going through the Panama Canal or going through other routes, it's of course not the most time efficient way of getting shipments from Asia to the east coast of Canada or from the west coast of Canada to Europe. So there is certainly considerations of that additional route. On the political side, we could probably talk for multiple hours as to how that works with Russia, the US, Canada, and other countries that would be involved in the, I guess, navigation, logistics, and various international agreements on how to do that. But that is something that is being monitored. It's still a few decades away, I would say, based on the general ice conditions. So yeah. Half an answer, but those are my thoughts.
No, that's awesome. My next one is also from Omar. Given the increased erratic nature of recent climate change events, do models trained on previous data fail to accommodate these recent changes, resulting in higher loss?
I can answer as well, or anyone else. Okay, so yeah, that's a very important point. Models are trained on historical data. So when we are trying to model future conditions, the level of accuracy or the level of reliability tends to be lower. There is new modeling techniques that help with that, and there's statistical process or probabilistic modeling that you can do to try to reduce that error. And then as computing power becomes more and more powerful, it's a lot easier to have scenarios that would cover some of those potential future storms. So that's been an important way of, I guess, trying to bridge that gap that 20 years ago was, from a computing perspective, just too complicated. So yes, things are getting better, but modeling the past is easier than modeling the future for sure.
I can step in this one. So as I said, I did a state space model. So to do the shark prediction. So I have to do a future prediction of sharks movement, but I don't know what's going on, how to do the training and the testing. So I suggest you choose as a time domain to do some cross-validation. Spare time, leave one cross-validation or stratified cross-validation to do those specific, especially related to time and space. You have to do those kind of different kind of cross-validation instead of just separating in different time, randomly separating in a test set and the training set. For this kind of test, you have to use the strategy cross-validation for that. So leave that for you to do some homework about statistical cross-validation. There's a different methodology to train how gonna to predict the future movement.
Awesome. Thank you so much, Joy and Emery. I have 2 more questions left, and then we'll move on to an actual discussion on the details of the challenge. And any questions that were put in the chat about the challenge itself, we will answer then. So our next question is, how can community-driven data collection initiatives contribute to local resilience efforts?
I can say this question actually, as I said, as I answered the last question for the panel discussion, I said the difficulty we have right now is the understanding of why we have to do those kind of research. Because the government spend a lot of money on that, because we talk to them, they kind of understand why we need this money, but the funding wasn't enough. And also the local education wasn't deep enough to understand what's going on for those tracking and receiving those data. And so I think that's part of it. And we, as OTN, we have some program. We have a local program to go to some local school to talk about what's going on. And I think that would be better for the government to give us some, like those kind of education system to go to school to give a tutorial, to give a talk to a high school student and also local farmer to let them know how important they can play a part of it. So next time when they say a receiver or glider, they won't just throw that into the garbage. They can just turn it back to us and also give us the data. And also when we give those kind of tags to, we get a more funding, we can have more tagging, like a battery. So more animal will be tagged, a certain area of the animal will be tagged. So we have more data collected, more detections. And so I think local community can all play a very good part of it. As a student, as a master student, they do the research. We have a lot of professors at the House University. They have their students. They are doing the tagging, this kind of project. That's very awesome. And so if everybody can participate in, I feel like if that day happened, everybody has the heart to connect the data, to pay attention to those animals. Of course, we can improve our process of data connection.
Well, thank you so much, Joy. I've got one more question for the panel, and then we'll move on. What role does interdisciplinary collaboration play in creating effective solutions for coastal resilience?
I can go ahead and start with this one. Yeah, I think inviting folks with different backgrounds to the table can be really valuable, because each person has different knowledge and understanding and ideas to bring. So for example, at CMAR, sometimes we work with different lobster harvesters to go out and deploy our gear. And those harvesters are able to give us such valuable information about their local waters, and advise us on where to put our gear so that maybe we can avoid entanglements with other fishing gear, or other ocean users. And those insights are things that, as researchers who don't spend a lot of time in these waters, we would have no idea. So having those different perspectives and working with different folks can be so beneficial. Yeah, and then I think it also kind of goes back to the previous question a little bit with the community involvement, just allowing people to have a sense of ownership over projects in their area can be so helpful for getting them excited about maybe implementing the changes that come from a result of that data collection effort. And maybe they'll be more willing to get involved, as Joy said, maybe not throw away that acoustic receiver that they find and instead return it to you and be excited about contributing to that research effort.
Awesome. Thank you so much, Nicole. So that's all I have for questions on my end. So thank you all so much to the panelists. Thank you so much for taking the time out of your day to chat with us. I thought it was a really great discussion and you all had very good presentations. So now we're gonna go into more information about the challenges. So panelists, feel free to log out now. Your job is all finished. Once again, thank you so much. The rest of this will be for our participants. Of course, if you want to watch, feel free. I'm gonna throw it back to Brogan now.
Like I mentioned before, the overarching challenge question is how can we promote coastal resilience? But the challenge is actually divided into 3 streams: on the water, in the water, and around the water. So on the water, this theme explores the effects of climate change on fisheries, shipping, and recreation. Changing ocean conditions can disrupt fish populations, reduce catches, and threaten commercially important species. Meanwhile, shifting ocean currents and stronger storms often create dangerous and unpredictable conditions that disrupt shipping routes, port operations, and recreational activities. So this challenge stream is just focusing about anything that happens on top of the water, mostly involving ships of some kind. The next challenge stream is in the water, and this theme examines the effects of climate change on coastal marine ecosystems. So warmer and more acidic ocean waters often result in habitat alteration, food chain disruption, reduced biodiversity, and impacts on the growth and reproduction of species. And as storms increase in both frequency and intensity, there is an increased risk of habitat destruction, nutrient pollution, and the introduction of invasive species. The last challenge stream is around the water, and this theme explores the environmental and socioeconomic impacts of climate change on coastal communities. So climate change has increased coastal vulnerability through sea level rise, increased coastal erosion, and stronger storms. These impacts can result in damage to infrastructure, flooding of low-level areas, community displacement, loss of livelihood, and the destruction of natural habitats. So now we're going to move on to the challenge rules. So I know this is a lot to take in for everyone, so we'll also be sending out an email with all of this so that you'll have all these details. But just to kind of give you a heads up before you get started, competitors must either own the rights or receive written permission for all of the software that they're using in your project. And if you do obtain written permission, you need to make sure to include it in your final submission. For the submissions, they can be as simple as an insightful bar chart or as complex as a machine learning model. We really just want you to be creative and leverage your unique skills and experiences. So competitors can participate individually or in a team of up to 5 members, and submissions must not include any confidential information. Each project must use at least one source of public data because this is the Ocean of Data Challenge, so data is very important. And you must clearly cite this source of data in your presentation, infographic, visual, or slides. So we need to be able to clearly see exactly where your data is coming from. And to help you get started, we have compiled a list of recommended data sources, which I'll share in the chat, but you can also feel free to explore and use your own data as well. Competitors must also live in Canada and have an active Canadian bank account, and this just ensures that we can deliver the prize money to you if you win the challenge. And lastly, competitors must be a current part-time or full-time student at a post-secondary institution in Atlantic Canada, whether that be Nova Scotia, New Brunswick, PEI, or Newfoundland and Labrador, or else you have to have graduated from one of these institutions within the past 12 months. So now moving on to the details regarding final submissions. In order to be eligible, every single team member needs to complete the team member registration form, and this is different than the Ticket Tailor registration form that you filled out to attend this kickoff. So the team member registration form is actually a Google form, and you can find the link to it in the challenge description document, which I'll be sharing along with this specific link as well. So I'll have all this in the chat, and you'll also receive an email with it. And then one team member from each team must submit the team concept submission form and the link to your recorded video presentation to info@deepsense.ca. And if you have any additional supporting materials, feel free to share those as well. So in terms of the actual video submission, you must present your idea in a video that can be shared with the judges. So there won't be a live presentation, it's just the recorded video. The video cannot be more than 3 minutes long, and it must be uploaded online. We prefer a private YouTube link if you can, but you can use other platforms as well, as long as you can share us the link. We won't be downloading any videos. So if it's an attachment that we have to download, we won't be accepting that. So make sure you're uploading it somewhere where you can send us the link. And in terms of the format, feel free to use any format that you like, whether it's a direct pitch to the camera or a narrated slideshow, it's completely up to you. And throughout the challenge, if you have any questions about the submission requirements or anything else, please email info@deepsense.ca. Now for the prizes, which I'm sure a lot of you are excited about. This year we have a total of 4 prizes totaling $1,400. So first place will be awarded $500, second place will be awarded $300, top creative design will be awarded $300, and the judge's choice will also be awarded $300. The final submissions will be assessed based on presentation quality, originality, as well as the design and potential value of the solution. So now moving on to the challenge schedule. As you know, we're kicking it off today with all of you here. So now you have 2 weeks to brainstorm, refine, and develop your solution. And then by 11:59 p.m. Halifax time on November 18th, each team member must have completed that registration form that I was talking about, and one designated team member must submit the team concept form along with the link to your video presentation to info@deepsense.ca. And I know I've mentioned all this already, but I'd hate for someone to miss out on a chance to win these prizes because they didn't complete all the necessary documents. So I just really want to make sure that you all know exactly what you have to submit to be eligible. And then from November 19th to the 25th, our judges will review all of the submissions and the winners will be selected. And finally, on November 26th by 3 p.m., the winners will be announced and we will send an email to everyone announcing the winners. And I'm sure we'll post it on our social media as well. So now we'll just move on to questions if anyone has any questions related to the challenge. And I did see there were a couple in the chat already. So first, I will share the important links that I was talking about. There'll be the challenge description, the Ocean of Data landing page, the registration forms, and also the data sources. So you can use any of the data sources that we listed, and you can also feel free to find your own data. Does the term coast include the exclusive economic zone of Canada? I think we want to limit that a little bit because the exclusive economic zone is so large and does incorporate parts of the ocean that aren't considered coastal. So if you're able to use it and actually limit the data to coastal areas or use it as kind of supplementary data, we don't want you to focus all of your data on that because a lot of the exclusive economic zone is parts of the ocean that aren't considered coastal. Let me see here.
We also had another one from Amara saying, what data sets will we be given access to, or do we need to scout for data ourselves?
Yes, perfect. So that's where I shared in the chat the link to the potential data sources. So any of those on there you can use. If you find public data as well that you're interested in, you are welcome to source it, but feel free to use the data sources that we've given you as well.
And then asked, is there a limit to how many slides we can include in the presentation/video?
There is no limit to how many slides you can include. It's more just the time limit. So you want to make sure that you're able to explain everything in the 3 minutes and that you don't go over the 3 minutes. So make sure before you send the video, if you record it and it's over 3 minutes, make sure you edit it down so that it does fit within that 3-minute time limit.
Perfect. Adele asked, can we give them any more examples for the around the water projects, such as which fields are mostly missing and what needs more work around the water?
Okay, so around the water would definitely be kind of the impact on the communities and more of the socioeconomic impact. So whether that be like the economy or local communities with like flooding, erosion, all that that's kind of not actually in the water but adjacent to the water. Does anyone else have any examples?
Yeah, toxic algal blooms, I think, could be ones that are
Mhm.
closer to the shore, yeah. I think. And then of course coastal erosion, especially the effect on housing and houses being brought into the water, losing national park areas to coastal erosion, the impacts of that. Lots of examples. Hopefully that helps.
Yeah,
Okay.
even losing like different habitats that are on land but near the coast, like
Exactly.
whether that
Piper
be
sleeping
like the
plovers.
dune areas, yeah.
Yeah, like Piper.
And you might be able to look at storms and things like that in that context as well, if you're looking at how they impact the shoreline.
Mhm.
Perfect. So we have another question. Does being in a team or going solo affect the judgment of a solution from the challenger's perspective?
It absolutely does not affect at all. The only thing it affects is how much money you end up walking away with, because if you're in a team, we'll divide the prize money amongst the team members, and if you're by yourself, you get it all. But in terms of the actual judging process, it has no impact on that whatsoever.
And in terms of the workload, like it can be a
Yes.
lot of work, and so having some team members to split that up is sometimes a benefit, but you're absolutely, you won't be judged on whether or not you have team members. Yeah.
Good. Omar also asked, what is the deadline to form teams? And can they look at the registration list to reach out to potential teammates?
Okay, absolutely. So honestly, the deadline to register is the same deadline as submitting your final project on the 18th. So anytime you want to do it before, we'll be accepting those team member registration forms right up until 11:59 p.m. on the 18th. So you can absolutely reach out to people who aren't involved in this chat or who didn't sign up for the kickoff event tonight. They're welcome to join, and if you have friends who might be interested, you can also share. People are welcome to register right up until the end.
Perfect. Maggie asks, can you define what we mean when we say own? When you said we have to own or have permission for a software use, can we give them an example of the software, of what they can and cannot use?
I feel like Emily might be better to answer this question.
That is a great question. I'm looking, this is specifically about software. I think as long as you have legal access to it and you haven't ripped it from the internet or illegally, then I think you're good to go. I know as Dalhousie students, and I think students enrolled in other universities and colleges as well, have a lot of access to different software tools. So I think as long as you didn't download it illegally, you're in good space. Now, if you are talking about data, that's a little bit different. The data sources that we are providing are all open to be used by everyone. If you're unsure about a specific platform, data set, software, anything like that, you can always send us an email. We can do a little bit of research if you're unsure. But we're just trying to avoid anyone using any product that they don't have legal rights to use. So Maggie, if you have anything specific that you want to check on, you can always run it by us first.
Perfect. I think that's all for questions in the chat. One more from Omar. Just to be clear, those who haven't registered for this at all can still register and be added to the team list form. Yes.
Yes.
Yeah, absolutely.
And just going back to Omar, the second half of Omar's earlier question, we can't share the registration data of all the other people to look for teammates. But if you wanted to use this chat right now to just see if anyone, float the idea of joining forces, then you absolutely can. We can facilitate it as much as we can, but we can't share people's contact information.
Yeah, for sure. And yeah, they can, even if they didn't register for this Ticket Tailor event, they can still register, but make sure they do fill out that Google registration form before the deadline.
Perfect. Another question, where can we get the team membership form? And if they're going individual, can we also use the team membership form?
Okay, yeah, so you can access the team member registration form. It's in that list. It's the third link in the list of links that I sent, but it's also on the DeepSense website. There's the Ocean of Data challenge page, and on there has the links to all the forms that you need to fill out, so it's on there as well. And yes, if you are going individual, still fill out that team concept submission form, but you can just have your one name on there, but everyone has to fill it out regardless of if you're going individually or in a team.
Perfect. Does anyone have any more questions? No? Wonderful.
Okay, great. Well, thank you all for joining tonight. And just a reminder that if any more questions come up throughout the challenge, you can email us at info@deepsense.ca. And we hope you all have a great evening, and we look forward to seeing your solution.